Hello and welcome to STEM Pursuits with Mr. Clausen. Today we are going to look at how to solve quadratic equations in Algebra 2, specifically lesson 5.5 for those of you following in my class. And today some of the things that we're going to talk about is we're going to introduce this idea of the zero product property. We're going to look at how we can solve quadratic equations by factoring using the zero product property, as well as look at a couple examples where we have calculator technology, specifically using Desmos and the TI-84. And what I'll do is I'll expect you to do skill 1 and 2, and then when I get to the first part of skill 3, I'll put a closed caption there indicating where you can skip ahead to the video so you can just watch the calculator method that you're using in my class. But overall, what I'm looking for is just looking at these first two skills and then learning a graphing technique so that we can use that to solve various quadratic equations. So with that said, let's get started here. So the first thing that I want to look at with you guys is looking at this idea of the zero product property. And if you haven't heard about this before, it is fantastic. This is actually something we are going to use all the time in this class, especially this unit in Chapter 6. And really, in terms of our formal logic discussions that we've had in geometry, the idea here is that if you have a situation where you A times B, and you have a situation that it's equal to 0, what you're able to do with this, and what the zero product property really says, is that anytime you multiply one of these factors by 0, it's automatically 0, right? So if you have A is equal to 0, well, then the whole expression is going to be equal to 0. And if B is equal to 0, well, then we can set that equal to 0. And you might be like, well, okay, like, yeah, you multiply anything by 0 and you get 0, right? So we can use that knowledge in terms of solving a quadratic. So because a quadratic has an x squared component, you always have two potential answers. So what you can do is you can actually take advantage of the zero product property to find the two possible solutions for any given quadratic. So with that being said, what we can do is if we look at a quadratic equation that's already been factored, we can say that, okay, if we have this situation, let's treat this as our A term, and let's treat this as our B term of our zero product property. So what this is really saying is we can say, all right, if x plus 5 is equal to 0, then we can conclude, using some simple algebra here, that if x is equal to negative 5, that this is a solution to this factored quadratic equation. And you would very clearly see that if you plug this in, you plug negative 5 here and you added 5, this would equal 0. And 0 times, regardless of what the second binomial turns out to be, is always going to be 0. And then the other thing that we can do is that if we see x minus 2, we can come to the same conclusion. So we can go x minus 2, we add 2 to both sides, and we see that if x is equal to 2, that this is the second solution. And what the zero product property does is it really simplifies this goal of finding solutions, because now we can just say that the answer to this problem, or the solutions to this given situation, is x is equal to 2 comma negative 5. And we can find all the solutions of a quadratic really quickly. So let's apply this to a situation where we actually are trying to solve an equation, where we're trying to solve a quadratic equation by factoring, but we're going to use the zero product property in addition to this. So the main thing that we want to keep into consideration here is that we have a quadratic term, we have a constant term, but the linear term is on the wrong side of the equation. In order to use the zero product property, we have to set this entire equation and set it equal to 0. So if we subtract both sides by 9x, okay, and then we go and set this up so that's in standard form, we go and we just set it up as x squared equals 9x plus 18 is equal to 0. And now we have a quadratic equation, and just based on what we've done in lessons 5.4, we can start splitting this apart. We see that this is a negative term here, So we're going to want negative factors to make our 18. So, you know, if we go negative 2 times negative 9, that doesn't work out. Negative 3 times negative 6. All right, we add those together, we get negative 9. We now have our B term, and we have our A times C situation satisfied here. So what this tells me is that I can take this quadratic equation and I can factor it into x minus 3 times x minus 6. And because I moved the 9 over here previously, I can set this whole thing equal to 0. So something that, you know, you could have set up a system of equations for, or something of that nature to try to solve for some of these variables that maybe would have taken some time in your calculator, can actually be isolated into a quadratic and factored very quickly. And now we can use the zero product property and just say that if x minus 3 is equal to 0 and x minus 6 is equal to 0, we can just simply look at these two circumstances and see very quickly that if x is equal to 3, that is a solution, and if x is equal to 6, that is also a solution. And we can find our solutions very quickly. And that if x is equal to 3 or 6, that we have an answer for this quadratic. So keep that in mind. If you can set up the zero product property and you can apply it to these binomials as such, you can find solutions to this really quickly. With that said, we can also apply it to situations where there's maybe a difference of squares. And again, we talked about this in the previous lesson, but don't forget those patterns, because if you see this and you see x times x and 2 times 2, you can see very quickly that this is a difference of square situation. You see x minus 2, you see x plus 2. This would all be set to 0 since it's already there. And if x is equal to 2, that is a solution here. Again, you're just trying to find the value that makes the binomial equal 0. And negative 2 plus 2 would be the situation here. So if x is equal to negative 2, that's the other solution. So again, if x is equal to plus or minus 2, then you have your solutions for your quadratic expression. And this is a very quick and easy method to use. The zero product property will really make solving quadratics a very quick and easy process for you. So let's move on to graphing technology and some of the things I want to show you there. So just like I was showing you previously where we're taking advantage of the zero product property, I still want to do that here. And again, it's just to make your life easier. So if we have a quadratic like this, first thing I'm going to do is rewrite it in standard form. So to do that, I'm just going to go negative 5x, and minus 4. Okay, Kachiga, cancel it out, Kachiga, cancel it out. And then we'll get 3x squared minus 5x minus 4. And this will all be equal to 0, okay? So write this down, because what we're going to do is we're going to take this equation and now we're going to go to Desmos and plug it in and find the solutions for this particular situation. So go ahead and we'll switch over here. All right, so now that I have you over here in Desmos with me, what I'm going to do is I'm going to punch in the quadratic equation that we just wrote down before. So if we go 3x squared minus 5x minus 4, and all I'm going to do is I'm going to set this equal to 0, okay? And this is really going to just treat it in a lot of ways as a standard form quadratic equation set equal to y. And a really cool thing about this is that, okay, it's going to find all the values for x and kind of set it up this way. But a really nice situation about Desmos, and this is literally as easy as it looks, we can go and we can set this up. Let's actually set up the x-axis to look from like -5 to +5, set up our steps. So I'm just going to set this up so that we can look at it for a ways up and down and just do it in steps of like 500. Okay, just so we can get a little bit of a look at this parabola. It's a pretty big parabola, but what we can do is using Desmos and just setting this equation equal to itself, we know that specifically the solutions for this given quadratic equation are going to be where y is equal to 0. Well, where does y equal 0? Y equals 0 at the x-axis here. And the nice thing about Desmos is all you got to do is you got to click there and you got to click there. And these two values that pop up here are your solutions for your quadratic equation. So that's all you need to do in order to look at this and find these solutions. Now keep in mind these aren't exact solutions, they're approximations. So there are some limitations there, and there will be examples on quizzes and exams where I'll ask you to find exact solutions. So keep that in mind. And this won't be a catch-all for everything. You'll still need to know how to factor in this class, because after this lesson we're going to talk about complex numbers, and those are things you actually can't see by graphing. But in terms of finding real solutions and looking for it, them in quadratic equations using the zero product property, this is a great method. Use it. It's going to be great. So now let's switch over to our next example, which is using the TI-84. So now that you can see how to do it in terms of using Desmos, and you see the general idea here, I'm also going to show you how to do this using a TI-84 calculator. And again, the process will be the same as we did in Skill 2. You have a situation where you have a quadratic equation here, but we want this in standard form and we want it to be equal to 0 so we can apply the zero product property again. So in this particular situation, we'll just subtract 12 from both sides, and what we'll get is 6x squared plus 31x minus 12. And again, we're kind of doing a situation here that's not super practical to factor out or anything. That's something that can be really practical about a calculator method. But now that we have this standard quadratic equation, what I'm going to do is I'm going to bring you over to... Alright, so now that I have you switched over to a TI-84 emulator, I'm using WebEmu. I have the quadratic equation written here that we're going to analyze. This is what I just wrote previously. And all I'm going to do is I'm going to turn on my calculator here. And this is a pretty simple situation to set up here. So since we already have the quadratic equation, what I'm going to do is I'm going to go to y equals, and I'm just going to plug y is equal to this quadratic expression. Okay, and what this is going to do, if we go 6x and let's hit squared here, and then we're going to add 31x, and then we'll subtract 12, and we can hit enter if we wanted. It'll call and tabulate all that in there. But when we go graph this now, we're going to see this kind of craziness here, okay? And all we need is two solutions. Keep that in mind. Whenever we're looking at a quadratic equation, something with an x to the second power situation, quadratic term, there should only be two solutions present. And we can see those two solutions here and here. Now, if you want to know where the solutions are, all we need to do is hit second and trace, which is going to indicate calc. All right. And we're going to go to 0. We're going to find the 0, which is the point where it crosses the x-axis, because if the equation is crossing the x-axis, then what that means is that it is including one of those solutions. So I'm going to take the point, and I want to be left bound here. Okay. Now I want to pick a point that's right bound to the right of that 0. And then it wants me to take a guess, and this only occurs, or you really would only use this if they were really close together. But we'll just pick a point in the middle. And what I have here is one of the zeros. Okay. So at 1 equals, that's pretty much just 0, right? Because that's 1 divided by 1 to the negative, or 0 divided by 1 to the negative 11th power. I mean, that's a really small number. That's 10 zeros, 1. That's practically 0. And then what we have here is that we have the x value. So one of our solutions is equal to x equals negative 5.5. We'll say 5.3. I'm generally pretty happy with 3 sig figs with this. It doesn't make sense to go write 8 sig figs because that never happens in real life, at least unless you have millions of dollars. Then you can get that many sig figs, but we're not dealing with that type of math right now. So we have one of the zeros, and then all we need to do to find the other 0 is hit second, and we're going to go calc again. We're going to go find a 0. Okay. And we'll just toggle over until we find the value that we're looking for. And if you really want to see where the cursor is, you can always hit the zoom button here and zoom out. I'm not necessarily concerned with that. I'm just going to go back to my graph. Oh, lost my progress there. But it's right where I left it. And I'm going to pick a point to the left of where it's intersecting. So just anywhere below it in this case. And then above it. I'm just going to pick that as the x point. And then I have my second x value. So I'll go in right here. And I'll say x is equal to 0. And let's go 3 sig figs again. 3, 6, 2. Okay. And then that would be my solution. So on your exam or your quiz, I may say like write it to the hundreds place, write it to the thousands place, and just I would go with those directions. If I don't specify, 3 sig figs is pretty safe. But then what this allows you to do is, again, something that was kind of complicated and messy before, you can just use this method and find pretty quickly that negative 5.53 or 0.362 are your solutions for this given quadratic expression. With that said, I hope this video was helpful. I will see you in class tomorrow, and I hope you have a great rest of your day, and thank you for joining me in this math lesson.